Hello, I am excited to present basics of developing with Llama 4 and IBM watsonx today. Here is the agenda for the session. We will go through an introductory overview of Llama and the recent Llama 4 models. We will discuss different ways you can run Llama and walk through how you can do that on IBM watsonx. Later, we go through various open source and watsonx available resources for you to be able to quickly start with hands-on development. Llama is a collection of open generative AI models that offer control and customization through open weights while delivering stability, performance, and quality. Let's take a closer look at some of the Llama 3 and 4 models. Llama 3.2 includes small and medium-sized vision LLMs, 11 billion parameters, also known as 11B, and 90B, as well as lightweight text-only models 1B and 3B that support image reasoning and on-device use cases. These models are designed to be more accessible, efficient, and private, with focus on responsible innovation and system-level safety. The Llama 3.3 7B model offers similar performance to Llama 3.1 405B model, allowing developers to achieve greater quality and performance in the text-based applications at a fraction of the cost. Next, let's delve deeper into the more recent Llama 4 models, Scout and Maverick. Meta has released two models in Llama 4 series. Llama 4 Scout is an MOE mixture of experts model with 17 billion active parameters and 16 experts. Scout has an industry-leading context window of up to 10 million tokens. This lighter weight model can fit on a single H100 GPU after int4 quantization. Llama 4 Maverick is also a mixture of experts model with 17 billion active parameters. However, it features a larger number of 128 experts. The Llama 4 models are designed with native multimodality, incorporating LLM to seamlessly integrate text and vision tokens into a unified model backbone. Early Fusion represents a significant step forward as it enables joint pre-training of the model with large amounts of unlabeled text, image, and video data. Additionally, we have improved the vision encoder for it. Notably, the Llama 4 models have expanded the number of main languages from 8 in Llama 3 series to 12 in Llama 4 series, while the training data included a much larger number of languages beyond those 12. The cutoff knowledge date for these models is August 2024. So what can we do with Llama? We can do language translation, specifically those 12 languages up from 8 in Series 3, visual context understanding, reasoning over large code bases, content creation, education and learning. For example, Llama can provide personalized learning paths and adaptive assessments, helping students learn more effectively and efficiently. We can build personal assistants, among other use cases. Llama 4's pioneering long context size and natively multimodal design helps with use cases such as image grounding. Image grounding is connecting or grounding text descriptions to specific visual elements or regions of an image. You may be familiar with bounding boxes. The model specifies those regions using the coordinates of the bounding box rectangle. Llama 4 provides multi-image understanding up to 5 images. Also, long document summarization, in-depth policy analysis, extensive dataset analysis, and finally reasoning over very large code bases. Next, let's discuss how to run Llama in general and then do a walkthrough of running it on IBM watsonx. So where and how can we run Llama? There are several options available, each with its own strengths and value propositions. Let's explore some of those options. One way to access Llama is through the recently launched Llama API by Meta on llama.com. However, please note that you may be waitlisted, so we will discuss alternative methods to get started immediately. You can also utilize Llama partner platforms. I have listed many of those in the footnote. Among those, today we'll focus on IBM watsonx. For a quick start, you can also download Llama locally to your laptop or GPU-connected notebook or a server directly from llama.com, Hugging Face, and other places. Furthermore, open source Llama Stack provides an optimized and standardized version available for download and installation on-premise, enabling you to quickly bring up an API or use it as an entry gateway to multiple hosted APIs with seamless transition between those. Given the time constraint for this event, using IBM watsonx may be the best and most relevant option. Let's dive into that next. Okay, let's get started running on IBM watsonx with basic Llama 4 chat. It's a minimal code, so it fits in one page and a slide. In practice, you may have more options available to you that you may want to use. After installation of IBM watsonx AI library, you can import it. You can get your URL, which might be different from mine. I'm using US South data center. You may be using another data center. Then API key, you get it from your account, also project ID. After creating API client, you choose the model ID. I'm using Llama 4 Maverick here. We are going to go through a list of other available models in the next slide. For the model, you can give more parameters. I used none. Space ID is optional, so this is the minimal setup, almost the minimal setup. And the message with the role user is simple: how many inches are in a foot? And here's the result. There are 12 inches in a foot from the model. You can add system, role, and other instructions as system instruction. Here are some of the available model IDs. Scout, Maverick, Llama 3.3 70B, Llama 3 405B, Llama 3.2 1B, which is the smallest one. There are many others, also other models like Llama Guard, etc., that we're going to talk about a little bit later. You can also use prompt labs from watsonx to see list of available models, also to get sample codes for Python, Node.js, or simply curl CLI. That also auto-propagates some of the settings that you can use in your custom code, such as API URL, which in turn includes your choice of data center as part of its prefix. So in this case, you can see I'm using US-South, but your mileage would vary. Here's a demo of Llama 4 Scout visual understanding capabilities as a personal trainer. developed by IBM, and we go through the details. You can follow the link below for step-by-step hands-on instruction on how to sign up for watsonx, create or import the notebook. IBM has watsonx has a notebook platform. You can create the notebook there and import it, and quickly run a sample Llama 4 demo. The model understands photos of available training devices and comes up with a personal workout plan for the user. You can find the code in the GitHub for this as well as the images. Okay, so this is the output from the model. You can see it has come up with a plan based on the images uploaded and identifying objects there. It has basic workout for beginner, warm up of 5 minutes, then directs the person to use rowing machine from the image for 5 minutes, cardio circuit, a lot of good details with specifying which device from which image, and then it goes to high intensity interval training, and finally a cool down of 5 minutes with a lot of good details. Next, let's go through some more useful resources and open source tools you can immediately download and use. Llama Cookbook covers the most popular community approaches, use cases, and the latest recipes for Llama text and vision models. You can use it to build with Llama. It covers getting started with inference, fine-tuning, RAG, and others. It describes how to solve end-to-end problems using Llama model family and how to use them on various provider services. Llama ecosystem includes multiple safety tools like Llama Guard, Prompt Guard, and Code Shield, which you can easily deploy in your application around the main model. Llama Guard is a high-performance input and output moderation model designed to support developers to detect various common types of violating content across text and images. Prompt Guard is a powerful tool for protecting LLM-powered applications from malicious prompts to ensure their security and integrity. Code Shield provides improved support for inference time filtering of insecure code produced by the LLMs. This offers mitigation of insecure code suggestions risk and secure command execution. It supports 7 programming languages. Llama Prompt Ops tool is a Python package that automatically optimizes prompts tailored for Llama models. It is particularly useful for transforming prompts that work well with other LLMs into prompts that are optimized for Llama models, improving performance and reliability of those. We have seen particularly strong performances when prompts are optimized for smaller Llama models, such as Llama 8B. You can see the effect of the tool using this Hotpot QA benchmark and how well it works on Llama 8B and 70B models. You can achieve even higher quality, performance, and optimization by fine-tuning on your unique datasets and use cases. For example, industry-specific knowledge adaptation, format optimizations, and others. If you're interested in fine-tuning Llama models, there is the TorchTune library reference implementation, among other open-source libraries. You can use parameter-efficient fine-tuning such as LoRa or full parameter fine-tuning. For these, you need access to a GPU node or nodes, or a fine-tuning platform and run it for an extended period of time. There are other tools available in ecosystem, such as new synthetic data kit for generating and augmenting datasets. It also helps converting your existing files into fine-tuning friendly formats for Llama. For example, user and assistant threads. Then you can fine-tune over the synthetic or augmented data. Here are more resources for developing with Llama. We covered some of these earlier. For example, llama.com is a place to download and get more information on the model cards, especially Llama 3 and Llama 4, alongside many other useful documents and pointers. The watsonx Getting Started page is also a very useful step-by-step guide. There is a recently published course by Meta and Andrew Ng's Deep Learning AI that provides a few Jupyter notebooks with which you can start developing immediately. It covers image grounding and other interesting topics. Earlier we discussed Llama Cookbook, which contains many useful samples and reference implementations. I encourage you to go through those and see useful samples from there. You can find more tutorials and samples from IBM as well, such as function calling, RAG, and fine-tuning. This link is one of the examples from function calling, but you can use prefix of this URL to explore more examples. Additionally, there are other IBM Watson AI samples that you can review and follow to learn more. You can use Llama Stack, for example, to bring up a local Llama API, or as an easy way, basically a gateway, to go through multiple hosted APIs seamlessly. This concludes our session. Thank you for joining.